Okay, so basically the example that the exercise that we were working on, I suppose it was, we wanted to find the mean and the variance of basically the first n natural numbers. We wanted to find the mean and the variance, and I need some more space here. I wanted to find the mean and the variance of the first n natural numbers. Now, when it comes to basically, for example, when you're working on first n natural numbers, first n, for example, I don't know, positive integers, negative integers, and that sort of thing, you do need to be familiar with series and progressions and sets and that sort of thing. And that's basically why I had to talk about all of those formulas before we could solve this problem. Because, well, in mathematics, you have to know everything. It's not possible to leave something out, then somewhere along the way you will get into trouble. Now, basically the first n natural numbers would be your data, or your observations would be, for example, 1, 2, 3, all the way up to n. All the way up to n. That is the first n natural numbers. So what that means is that now if you want to find the mean of these numbers, you have to, you know that the mean of basically n observations is basically sigma, we call it basically x bar, and we said that that's equal to basically sigma f of I x of I, meaning that the frequency of each of those observations times each observation as I goes from 1 to n, divided by sigma f of I as I goes from 1 to n. So this is only the number of those numbers. So you can call this, for example, I can call this n or whatever you want to call it. In some parts of the book it's been written as capital N, but that's basically the same thing. And then sigma f of I x of I, since the frequency of each of those numbers is 1, meaning that each of those numbers has been repeated only once and none of them has been repeated more than once, you can leave out f of I and write this as just sigma x of I as I goes from 1 to n. Now your sigma x of I is equal to the sum of the first n natural numbers. The sum of the first n natural numbers, which is equal to sigma, basically, for example, x of I, you could say as I goes from 1 to n. And we in the previous video we showed that is equal to n times n plus 1 divided by 2. We showed that was, and that's basically why we had to take the time to write down all of these formulas. So we showed that basically this was equal to n times n plus 1 divided by 2. So I can write this as n times n divided n times, I can write this as n times n plus 1 divided by 2 divided by n, which I can write as n times n plus 1 divided by 2n, and if I can simplify the n's, I will get n plus 1 divided by 2. So the mean of those numbers is going to be n plus 1 divided by 2. Now the variance of those numbers is a different story. Now this is not here actually. The variance of those numbers is I don't know if that's the formula to use. No, not this one. I'm going to use, for example, this formula here. The variance of a set of observations is basically, we said that sigma squared is equal to 1 over n sigma of f of, there has to be some f of I over there as well. I don't know why I haven't written the f of I here. That is the mode. That is the step deviation method. But as far as I know, f of I has to be there. Let me see. Okay, so I'm going to take a look at the solution here. Oh, by the way, I have showed you this before, but if you need these solutions, you can always go to tiwariacademy.com, and then over here you can go, for example, right now we're doing class 11, for example, mathematics, and then you can go, for example, to the chapter you're doing, for example, the statistics solutions, and then now we are doing basically exercise 15.2. So exercise 15.2, you can see the solution number 2, which is right now it has some problems, I suppose. Okay, so I don't understand why in the formula for variance we don't have frequency. Let me take a look at the... Oh, okay, it was like... Well, the frequency, they have not written the frequency because we're talking about these natural numbers, and of course the frequency is for each observation is 1, so you don't have to write it. But otherwise, variance is equal to 1 over n sigma, sigma basically f of I times x of I minus x bar whole squared as I goes from 1 to n, right? Now, since here basically the frequency is 1, so you can just simply forget about that. And then what you can do is that basically I can write sigma squared is equal to 1 over n 1 over n, and then I can write sigma of basically I goes from 1 to n of basically x of I, which is basically I can take as x of I minus x bar. Now my x bar over here is n plus 1 divided by 2. N plus 1 divided by 2, and then I have to raise this to the second power, and that's basically my variance. Now I need to calculate what this thing is. So now to calculate this thing, what I need to do is I need to basically treat this as, for example, a minus b raised to the second power, which is equal to a squared plus b squared minus 2 times ab. So this is going to be equal to a squared, which is basically x of I squared, plus basically x plus 1 whole squared divided by 2 squared, which is equal to 4, minus Now this part over here is negative 2 times a, which is x of I, times b, which is x plus 1 divided by 2. These 2 and 2 will cancel out, and you will get negative x of I times x plus 1. So over here you will get negative x of I times x plus 1, right? So that is basically this part over there that I can write here. So I can write 1 over n sigma of basically x of I squared plus x plus 1 squared divided by 4 minus x of I times x plus 1. And then I can write this as sigma basically of this whole thing as I goes from 1 to n. Now, I can basically what I can do is that I can rewrite this as 1 over n times sigma of, for example, x of I whole squared as I goes from 1 to n, plus sigma of basically sigma of x plus 1 raised to the power 2 divided by 4 as I goes from 1 to n, minus sigma of, and let me basically simplify as I'm going along. So you see over here these terms, this is not x of I, this is only x. So of course x of I and x are different. X of I is dependent upon I. X has just one single value. So that means that x plus 1 and 4 and the whole expression is not dependent upon y. As you change y, as I changes from 1 to as I changes from 1 to n, this is not going to change. This is going to remain x plus 1 raised to the power 2 divided by 4, which you can basically treat as a constant. So I can write this part, I can write it as x plus 1 raised to the power 2 divided by 4 times sigma of 1. Sigma of 1. And as I goes from 1 to n. Now sigma 1 is basically sigma of 1 as I goes from 1 to n is basically so what this means is that this is just equal to let me see, if I multiply this, I will get the same thing. So this is right. So this is sigma of 1 as I goes from 1 to n. And when I is equal to 1, this is 1. When basically, as you can see, when I is equal to 1, this remains 1. When I is equal to 2, this remains 1. When I is equal to 3, this remains 1. And even when I is equal to, all the way up to I is equal to n, this remains a 1. So the meaning of this expression is 1 plus 1 plus 1 plus 1 all the way up to n terms, which is equal to n, right? So you can write this part. You can just simply, instead of this part, you can write an n, so you can put this n over here, and so write it as n times n plus 1 whole square divided by 4. So I write this part as n times n plus 1 whole square divided by 4, and then And then over here I have sigma, I would have negative sigma x of I times x plus 1 as I goes from 1 to n. And so again, this part is not dependent upon I, so I can take it out. So I can write this as x plus 1 times sigma of x of I, sigma of x of I, as I goes from 1 to n, right? So that I can write this way. Now we said that sigma x of I as I goes from 1 to n, that's the same thing as what we showed, that's the same thing as what we found here, and that's again why I took all this time to go through all of these formulas. So this is the same thing as sigma k as k goes from 1 to n, which is equal to basically n times n plus 1 divided by 2. So what that means is that this I can write as this is not right. So I can write this as n plus 1 times, and then sigma x of I as I goes from 1 to n is then n times n plus 1 divided by 2, which is equal to n times n plus 1 all squared divided by 2. So this part I can write n times n plus 1 whole squared divided by 2. And that is basically this part. And this part I can change as well, meaning that I can write sigma x of I squared, and this is an n. So sigma x of I squared as I goes from 1 to n is the same thing as sigma k as k goes from 1 to n, and we showed that was equal to basically n times n plus 1 times 2n plus 1 divided by 6. So this part I can write it as this thing over here. So there is a 1 by n multiplied by the whole thing. There is a 1 by n multiplied by the whole thing, but otherwise it's n times n plus 1 times 2n plus 1 divided by 6, and there is a 1 by n multiplied by the whole thing. So that is now the basically everything put together. And now what I can do is that you can see that n is common here, n plus 1 is common here, and I can take a 2 out of the denominator. So I can take n times n plus 1 divided by 2 out, and then I have a 1n over here as well, which is already out. So I can write this as n times n plus 1 is out, a 2 is out here, so that's 2n plus 1 divided by 3, plus over here n and n plus 1 take out, so you'll be left with n plus 1 raised to the power 1 divided by 2, and over here there is no denominator anymore because you take the 2 out, n and n plus 1 out, so you get n plus 1. And of course these parentheses are important because you have a negative sign here. And then you can simplify these two. And what you can do is that you can write this as n plus 1 divided by 2 times, take the LCM as 6, for example. 6, that's 2 times 2n plus 1 plus 3 times n plus 1 minus 6 times n plus 1. Add all of these together and you will get your answer. So you have the numerator here becomes 4n plus 2 plus 3n plus 3 minus 6n minus 6 divided by 6, and over here you have n plus 1 divided by 2. And then you have 4n plus 3n minus 6, and this is 7n minus 6n is equal to 1, basically n. 4n, 3n, 7n minus 6n is equal to n. And you have 2 plus 3 is equal to 5, 5 and 6 is negative 1. So that's n minus 1 divided by 6. That is n minus 1 divided by 6 times n plus 1 divided by 2, which is the same thing as n minus 1 times n plus 1 divided by 12. Which is basically n squared. This is the same thing as a minus b times a plus b, which is the same thing as a squared minus b squared. So you can write this as n squared. You can write this as n squared minus 1 divided by 12. And that is the correct answer, meaning that this is your sigma squared, which is also called the variance of the first n natural numbers. Okay, so that is that. Now, the next question that we have here is question number 3. We want to find the mean and the variance of first 10 multiples of 3. First 10 multiples of 3. We want to find the mean and variance of the first 10 multiples of 3. 10 multiples of 3.